Hello everyone, welcome back to our channel. This is series 12, Ecotech Fusion Intelligent Ideas Next Generation. Moving on to the ideas, the first idea for today is multi-language error handling and debugging interfaces in a unified dev environment. So here the project focuses on design and development of a unified debugging and error handling interface that supports multiple programming language within single development environment. That is nothing but we call it as uni-dev environment. So the goal is to streamline the debugging process for the developers working on polyglot projects, that is code base that uses more than one languages such as Python, C++ or JavaScript. So here the system will detect, interpret and display the compiler, runtime errors, exceptions and warning across languages in a standardized, user-friendly format regardless of language syntax or across the backend. It also supports cross-language stack tracking, breakpoints, and step-by-step debugging, enhancing the developer productivity and project maintainability. So what is the innovation highlights? Language agnostic error interpretation. So here it translates a language-specific error message into a human-readable, consistent explanations across all supported languages. Unified stack trace viewer. It allows viewing multiple language stack traces in a single flow. Say for example, from a Python frontend to a C backend. Cross-language breakpoint management. It sets and manages the breakpoints across the files written in different languages from one interface. Smart debugging suggestions means it suggests the fixes or documentation links based on the type of error detached, that is either via AI or rule-based matching. Custom debugging engine bridge. It uses plugin modules or adapters to integrate existing debuggers like JDB, PDB, GDB under one umbrella. What is the future scope? AI-powered error explanation and fix suggestions. It means it integrates LLM to suggest fixes, code correction, or bug root causes in real time. Cloud-based remote debugging. It allows debugging or deployed services or cloud apps running in multiple languages from single web dashboards. Voice or chatbot debugging assistance. It implements a voice-based assistant or chatbot that explains the error that causes and suggests the comments. Automatic bug report generation. It auto-generates the standardized language-agnostic bug reports from debug session to streamline the issue tracking. IDE integration plugins. So it develops a plugin for VS Code's Eclipse or JetBrains IDEs to bring multi-language debugging to a popular tools. Finally, Polyglot DevOps debugging suite means it integrates with CI or CD pipeline to track and debug build errors across different language stages. Moving on to the second idea, multimodal sensor fusion for enhanced gesture recognition in smart prosthesis. So here it focuses on integrating multiple types of sensors such as EMG, that is electromyography, IMU, inertial measurement units, force sensors and flux sensors into a wrist disarticulation prosthesis to accurately recognize the user intent and gesture. The collected data from these diverse sensors is fused using advanced algorithms like Kalman filter, sensor fusion frameworks or AI-based fusion models so that it enables the precise and real-time control of prosthetic hand or wrist. The multimodal approach helps compensate for the limitation of single sensor system, improving the system robustness against noise, motion artifacts and environmental interference. What is the innovation highlights? Multimodal input combination. It uses combination of muscle activity, limb motion and finger bend to understand the user intention better. advanced sensor fusion algorithm. So it employs Kalman filter, Bayesian inference, or ML models to combine and interpret the sensor data in real time. Robust gesture recognition means it enables complex and nuanced gesture control such as pinch, grasp, twist, and wrist rotation even in dynamic environment. Improved fault tolerance. If one sensor fails or provides noisy input, others can compensate, making the system more reliant. Personalization through training. It incorporates adaptive learning where the prosthesis improves recognition accuracy based on individuals' muscle behavior over time. Future scope. AI-based dynamic adaptation. So it integrates with deep learning models, that is CNN or RNN, for automatic gesture classification with high precision. Cloud-based gesture libraries. So it builds cloud connector databases of common gesture to help train and improve prosthetic behavior across multiple users. Haptic feedback loop, that is, it adds a tactile feedback system. Why? Because for real-time sensory feedback like vibration, pressure, so that it improves the user's connection with the prosthesis. Integration with AR or VR for training. So it uses virtual reality environment to help users train and improve the control over their prosthetic hand through guided interaction. Battery optimization with smart power management. It utilizes sensor data to activate only necessary modules, conserving battery life and improving the prosthesis. The next idea is about experimental analysis of energy efficiency in solar flower waste dehydrators. So here the project focuses on design and development and experimental evaluation of solar powered dehydrator, especially intended for drying flower waste from temples, flower people or public events. The primary goal is to maximize drying efficiency using renewable solar energy while minimizing power consumption and processing time. So the dehydrator will be tested under various environmental conditions like sunlight intensity, ambient temperature, humidity, and some design parameters like angle of inclination, insulation, airflow rate, so that it analyzes its energy efficiency, moisture reduction rate, and the overall performance. So the flower waste, once dried, can be repurposed into an organic fertilizers, handmade paper, or even natural dyes. Here, the innovation highlights are specialized design for flower waste. So it optimizes for delicate texture and moisture content of flower petals and stems. Real-time monitoring means it uses sensors, that is to measure temperature, humidity, solar radiation, and data logging system to monitor the internal chamber condition. Adjustable solar collector angles means modular design allows altering the angle of solar panels or glass covers for seasonal optimization. Thermal insulation and airflow control. It uses eco-friendly insulating materials and DC fan system to control the internal air circulation for uniform drying. Comparative energy analysis. So it evaluates the solar energy utilization rate, drying time versus energy gain, and carbon footprint reduction compared to the electric dryers. Future scope. Hybrid solar electric dehydrators. So for use in cloudy or rainy regions, so that it maintains a consistent drying efficiency. AI-driven drying time prediction means it uses ML models to predict optimal drying times based on weather forecast and flower type. Scaling for industrial application. Large-scale floral waste dehydrators for temples, flower markets, and city beautification departments. Integration with mobile waste collection units. So it combines with solar-powered carts that collects and dehydrates the centralized system. Smart dashboard for efficiency tracking. So it uses real-time IoT enabled dashboard for monitoring performance and maintenance and the final output. community-based micro enterprises. So here what happens is it empowers the rural women to produce value-added products like natural colors, incense from dried flowers. The final idea for today is volatile organic compound, that is VOC, sensor network for spoiled meat detection. Here the project focuses on developing an IoT-based sensor network that detects the spoilage in meat products by identifying volatile organic components released during the decomposition. So as the meat spoils, it emits a specific gas such as ammonia, hydrogen sulfide and methane, which can be sensed using VOC sensors like MQ series. That is, MQ series is nothing but MQ 135, 136 or 138. So here the system will use Arduino microcontroller to process the sensor data and GSM or Wi-Fi modules to send real-time alerts when VOC levels exceed a defined threshold. It helps in early detection of meat spoilage in supermarkets, cold chains, meat storage facilities and transportation units. What is the innovation highlights? Gas-based spoilage detection. So here it directly measures the chemical changes in air due to organic decomposition, which becomes more reliable than visual inspection. Multi-gas VOC detection means it combines the data from multiple sensors to improve the spoilage detection accuracy and specificity. Real-time alerts. So it sends SMS or IoT notification when spoilage is detected so that it can reduce the health risk and produces and protect losses. Networked sensor nodes. Multiple meat storage areas can be covered using distributed wireless sensor networks, that is WSN. Battery operated or solar operated option. So it is ideal for use in rural cold chains and meat transportation trucks with no reliable power sources. What is the future scope? AI-based spoilage prediction. So here it trains the ML models to predict the spoilage based on VOC patterns, temperature and humidity trends. Cloud integration for smart inventory. It sends VOC data to a cloud dashboard enabling smart tracking of meat's shelf life in large facilities or supermarkets. Blockchain linked cold chain logging. It means it adds blockchain for tamper-proof freshness records, improving the transparency in meat supply chains. Mobile app interface. So it develops a companion app for the restaurants, retailers to get the spoilage alerts, histories or tips to maintain the healthy meat. Reusable calibratable sensor modules means it designs plug and play modules with self-cleaning features for long-term sustainable use. Multi-food extension. It adapts for fish, dairy products, fruits, vegetables by tuning the sensor threshold and the VOC profile. Hope you are interested to know about more ideas like this. Please stay tuned for more information. Thank you.